Okay, good. So the idea of this presentation, it's my idea at least was, let's say, show to you, let's say, which are the key topics or the key points that we are looking for in a mango tree in order to give to the mango plant the chance of support higher yields with higher quality. Our market, it's mainly export market, so it's not only yield, but we need to have yield with quality in order to export these mangoes, because these are the market that for us in Brazil that pay the best price. So our targets really have higher yields with export quality in our mangoes. So we will talk about on the presentation of today a bit regarding environmental conditions. So this is really important. Then mango nutrient extraction, that is also guide us in the amount and balance of nutrients that we need to supply to the plant, and some kind of fruit growth physiology, because also teach us a bit on the way as we need to, let's say, on the ratio that we should use between the elements for the fertilization. Regarding the environmental conditions, plants, let's say, are growing in an environment that this environment, depending on the condition, can, let's say, send to the plant signs to be more vegetative or more generative. Now, generative, we use it as, let's say, for reproduction, let's say, in vegetative, for vegetative growth. So, for example, the thermal amplitude. Thermal amplitude is the difference between the minimum temperature and the maximum temperature in a certain period of time. Normally, we use it 24 hours a day. So it's the difference between the minimum temperature and maximum temperature in 24 hours. If you have a low difference between the maximum, for example, during the day, 30 degrees and the maximum, and the minimum, for example, 26, this is 4 degrees as delta between the maximum and minimum. And this is a condition that normally naturally gives the plant, let's say, the signal to be more vegetative. And the other way around, for example, if you have 33 degrees during the day and maybe 20 during the night, that is 13 Celsius degrees as a difference. So this is, let's say, makes the plant more generative. So pay attention, for example, on this difference. It's important. The relative air humidity. If you have a high relative air humidity, it's also the nature giving a sign to the plant be more vegetative. And if it's more dry, with lower humidity, then it's more generative. Radiation as well. So as higher is the amount of radiation, this makes the plant more generative. Low radiation, more vegetative. It's natural. And low radiation is phototropism. So plants start looking for the light and start to stimulate the growth. Electrical.
Felipe, sorry to interrupt. There is one question from Carlos.
Just on temperature,
please,
Felipe,
Carlos.
Between vegetative and generative. So I'm talking other crops. So my specialty is in other crops. But we used to work on about 6 to 8 degrees variation between day and night was enough to be generative. Is that the same in mangoes?
How much you used to say the difference between day and
night? Ideally 8 degrees. So if we had 8 degrees difference between day and night, that was enough to be generative. Is mangoes the same?
Yes, it is. It is similar. As high as I would say that 8, let's say, could be enough, especially for, let's say, horticultural crops, especially if you go more for other fruits, and maybe horticultural fruits, so melon, watermelon, and all the other ones. I think that 8, it's, let's say, a bit on the edge for the mango. It's starting the process. As higher is this difference, the better. So if you go to, instead of 8 for 10 or 11, 12 or 13, you see even, let's say, better results. And we can clearly see this on the flowering induction. For example, when we are applying, let's say for example, here we used to apply normally potassium nitrate for flowering induction, sometimes calcium nitrate, sometimes potassium nitrate, depending on the condition. And normally, for example, when we are doing, but because also in the area where we are doing, let's say, flower induction all year round. So we do it from January till December, all year around. We are always flower induction. And it's clear when we can see the difference, for example, when you have a lower delta, we need to use higher concentrations and sometimes do, let's say, 6, 7, 10, 11 applications of nitrates to get the flower induction. And when we have a higher delta, for example, 13 degrees or above 8, normally we can do it with 2 or 3 and even with a lower concentration. So this is something, but 8 degrees, as you mentioned, Carlos, I think that it's on the edges when you can start to expect some good response for the plant coming from this sign from the environment. But as higher is this delta, the better.
All right. Yeah.
Okay.
And I get that. But we just used to benchmark at 8. So anything greater than 8, we knew we were pushing towards generative action. So that was where we were steering the crop. Anything less than 8, we had to use other levers like EC or nutrition to then push it generatively.
With the nutrition, this is a bit related with EC and also the nitrogen potassium ratio. So regarding nutrition, we needed to have a look on these 2 points. One is the EC, for example. If you have a low EC, if you keep a low EC at the moment that you need, a low EC makes the plant really comfortable, so also stimulates vegetative. So a bit higher EC, especially at the flowering moment, it helps to give a sign more generative. But it's not only EC, because EC is the sum of all minerals that you have in a nutrient solution. So you can have a higher EC, but for example, if you have a higher EC, because your nitrogen level is too high, that will be not good. Then you come to the next point, that's the nitrogen potassium ratio. So if you have a high nitrogen potassium ratio, nitrogen content in comparison with potassium, it's also vegetative. And the other way around, if you have more potassium, a low nitrogen in comparison with potassium, then you have a more generative. So regarding the nutrition, it's always good to pay attention on the EC and on the nitrogen potassium ratio. Ideally, to give you as a reference, for example, before the flowering period, your nitrogen content in the leaves should be below 1%. So normally, if you do a leaf analysis before flowering, if you want to have an idea to decide if you start to do it or not, if your nitrogen level is below 1%, that's good. But if it's higher than 1.2%, normally you have, let's say, maybe it's not a very good amount of flowers as you expected. So this is something that you can measure. For example, you can monitor this, checking the nitrogen level in the leaves. You can then do this. And then we have also the amount of leaves regarding fruits as well. So a very bushy crop, it's also tending to be more vegetative than generative. The root system, so a very well-developed root system as well. It's more vegetative than generative. So that's why in some countries, they used to manage with irrigation for this. So before flowering, they will start to reduce a bit the amount of water applied to generate some kind of minimum, let's say, stress on the plant, not in the level that the leaves became yellow and fell down and this thing that's too hard. But indeed, it's good if before the flowering moment, we do a kind of irrigation management, reducing a bit the amount of water. So we decrease a bit the root activity and generate some kind of minimum stress. As you can see.
Felipe, sorry, a question from Kalum.
Yeah, please.
Yes. Hello, sorry, it's Felipe. Sorry I'm late, guys. Technical difficulties. Callum here from Darwin. I was just wondering, sorry, is these factors based on a particular growing region? I'm just thinking because the nitrogen level in the leaf being less than 1%, I don't think I've ever seen that in a test, no matter what the nitrogen inputs of a crop have been in the NT. I've never seen leaf levels below 1% nitrogen, essentially. Is this, I was just wondering, is this tailored to a specific region, or is this sort of just a general speaking numbers?
Oh, this is general speaking. In fact, for example, this data, I learned it many years ago in Spain. So I took it, for example, this concept from the greenhouse area in Spain, and I started to use it really low. And if you never see, let's say, nitrogen levels, let's say that are less than 1% or less than 1.2, let's say I put 1.2 as a maximum for normally in my farms, I never do flower induction if my nitrogen levels are above 1.2. I always, let's say, start to raise them down. Now, one thing, if you never saw it, it's okay, maybe check, let's say, the nitrogen management that you are doing. And nitrogen management can be the amount that you are applying or the moment that you are applying, the way as you split the same amount of nitrogen you are applying. So I'm not so sure, for example, in a year, how much nitrogen you are applying, but here, in order to keep the control or the nitrogen around 1%, if you're taking the whole year, considering the vegetative period and then the generative period from flowering ahead, for all year around, we are using, let's say, normally maximum, that will be something between 60 or 70 kilos of nitrogen per hectare, not more than this. And this, I'm telling you, supporting yields that are in an average of 40 metric tons per hectare. So I'm not so sure if you can tell me, for example, your reality, normally how many units of nitrogen you apply in a year and in which yield average you have in your area.
Yeah, I can't imagine it would be more than, it wouldn't be more than sort of 60, 70 kilos, speaking for like a Kensington Pride crop, which is what we're mainly dealing with. Very little nitrogen inputs, say, maybe a little bit post-harvest, but during the season, the main source of nitrogen would be coming from foliar spray, like you're talking about your potassium nitrate induction sprays. Maybe the fact that we get a lot of sort of atmospheric nitrogen from wet season storms might be playing a role why you can't get that nitrogen down as well, and leading into that sort of flowering period over the wet season. So not sure to what extent that sort of contributes to the high nitrogen, but yeah, it just seems like that nitrogen is naturally high somehow, regardless of whether you put 10 units of N or 100 units of N, you know what I mean? So even crops that sort of have been neglected for a few years, but like I say, I don't know the history of all these crops that I'm dealing with as well. So, there could be residual nitrate happening in the system that is still lingering, I guess, is another factor.
Yeah, so it's quite possible indeed. That makes sense. Could be, let's say, a lot of environmental available nitrogen as well, and then you never see it. But normally, what is the average nitrogen level you see in your leaf analysis when you do a tissue analysis? What is the average nitrogen level that's there normally?
1.2 to 1.4 usually.
That's okay. Yeah. Let's say you've been on the maximum limit that normally we use to work here. We don't have too much natural nitrogen available here, unfortunately. I wish we have. So then we can reduce even more the amount of mineral nitrogen that we apply it. But it's on the edge here. Let's say we have 1.2 as a cutting line. It's risky when we do flower induction in areas in our conditions with more than 1.2, for example. So this is a bit.
Felipe, just following up on that. So if we're sitting at a 1.2, so at the higher end of your scale in tissue, what should our ratio be between nitrogen and potassium then? Should we be 1.1, 1.2? So how much more potassium should we be doing to try and balance it back out so we can get our flower induction?
That's very good. This is something that I will talk a bit more further, especially during the fruit development stage. So here, let's say, but on this case, here, if you want to do it, let's say for a leaf analysis for pre-flowering, to define the pre-flowering, potassium is not, let's say, really that relevant. Let's say for that moment, it's really mainly nitrogen. Potassium will be important for flowering, Because if, imagining that we apply the nitrates and if we have inflorescence emission and not another vegetative emission, if we have inflorescence emission after we spray the nitrates, then potassium has a crucial role because the carbohydrates transport from the leaves to the inflorescence, that's mainly done by potassium because potassium has a higher mobility inside the plant. It's, let's say, the element that plant uses to transport carbohydrates. And then if you do spray nitrate for flower induction and then an inflorescence come, that means, let's say, the plant will concentrate a lot of carbohydrates in the inflorescence for fruit setting and for feeding the fruits and all the process. So you need to plant naturally, you need to start to send carbohydrates to the inflorescence. And there potassium has a crucial role. And actually this is the main benefit of use potassium nitrate for flower induction instead of calcium nitrate. Because with potassium nitrate in the flower induction, you are already giving extra potassium, supplying your plant with extra potassium, that if the inflorescence come, that extra potassium will give you a benefit because the benefit will be increasing the carbohydrates transport for the inflorescence, and then you have a better fruit setting and a higher yield. Actually, that is the difference between do flower induction with using potassium nitrate or calcium nitrate. Because at the end, what really make the click for the, let's say, the inflorescence emission is the nitrates. So then no matter if the nitrates came from potassium or calcium, that's irrelevant. But when you have the inflorescence, to have extra potassium in the plant, bring you a benefit to increasing the carbohydrates transport from the leaves to the fruits. And that's why normally in higher yield areas, they use potassium nitrate instead of calcium nitrate for flower induction. But we will come back to the nitrogen potassium ratio during the fruit, physiological fruit development stage, because there yes, this ratio between nitrogen and potassium has a main role, and there we have a very defined ratio between nitrogen and potassium. But for pre-flowering, they don't care too much about the potassium at that moment. If the nitrogen level is low, you can do it. And if you do it with potassium nitrate, so then you really don't need to concern regarding the potassium in that time. You have enough potassium in your plant just doing the flower induction spraying with potassium nitrate. So it's not relevant in that moment, but for fruit development stages, yes, it is very relevant. So just to give you an idea regarding in the conditions where we are growing mangoes. So we are growing mangoes in this area in the northeast of Brazil. It's more really, if you see this white line here, this is the San Francisco River. It's the second biggest river in Brazil. The first one is the Amazon River, as everybody know, I think. And the second one is San Francisco. And this is from where we take the water from irrigation. And exactly here in this area, in the, let's say, in the core of the northeast of Brazil, we are growing up our mangoes. Then it's a semi-arid climate here. It's a semi-arid, so the average annual rainfall, it's about 500 millimeters. Of course, in some years we have 1,000. In other years we have 300, 400. So if you take the historical average, it's 500 millimeters. But I need to tell you that this is increasing, as we see everywhere in the world. Also, if you take the average from the last maybe 5 years, so probably this is already more on around 700 and 500. But this is the historical average of the area. And normally these 500 or 700 these days, they happens between December and March. So we have let's say a well-defined rainy season that normally between April and November, it is completely dry. We have no rain. So that's why we have lucky to have the San Francisco River here, because then we can use very good water for irrigation. The average annual temperature is 28 Celsius degrees. And the average minimum and maximum is between 20 and 34. This is the average. But if you go to the extremes, okay, the extreme lower temperature here will be maximum 18 Celsius degrees, not less than this. But the maximum here can go up to 47, 49 in the extremes hottest day as well. So, but this is the average minimum and maximum temperature. So then I hope with this I can give you an idea about under which conditions we are getting the results that I will show you today. And also you can compare with your reality. Because I don't expect that you need to do exactly the same in Australia as we are doing in Brazil, are completely, I think, different conditions. But maybe the concepts and showing to you the results that we are getting can give you some idea, or maybe try some new things in order to look for increasing yields and quality and better results. So regarding environmental conditions, one thing very important to the plant is light interception. And light interception, it's mainly because of the photosynthesis process, and carbohydrates build up, let's say, build up a reserve of carbohydrates. So light interception is key of that. And this concept of light interception, what we'll define is the way as we pruning our plants. So, for example, when we have here in our conditions, plants that the planting line, let's say the mark of plantation, are going from the east to the west direction, we normally do this type of pruning as you see here, with an angle here, and we cut on the top, we stay really like this, because then the sun will be passing by from east to the west, always on the top of the plant. So then we have, let's say, this flat top with this angle on the sides. And the idea is that with this, we can increase the light interception from the plant to the sun, because the sun is always passing by over the line, over the planting line all the time, because it's east-west. So then with this, we can increase the light interception, increase the photosynthesis and carbohydrates production. Or on the other way around, when you are planting lines that are going, let's say, on the north to south direction. So this means that the sun, if you follow here my red dot, will pass by, like say, on this way to the plants. So we make the middle, you can see here the middle of the plant is kind of open, because when the sun goes coming here, you also have light coming from inside here, and when the sun is here, light coming from inside here. So then we also increase the light interception. So we do a pruning with a kind of V in the middle of the plant. So we have the sun on the sides. When the sun is passing by here, it's also sun coming from inside and here. So light interception is something that we really should consider in order to define the way as we will do the pruning in our plants. And here I want to show you something that I received from Australia. Maybe you know this guy, Ryan Orr. He worked on the Department of Primary Industry in Queensland and also in James Cook University in Australia. So this is experimental trials that they are doing there in Australia. This is a narrow espalier for high density mangoes. You can see the distance here, it's very short. And they are testing this under evaluation. With very good local results till now. And also another method that is narrow palmate. It's a bit different also for high density mangoes. So they are testing different ways to do the pruning. But the concept is always the same. We need to have a higher and closed vegetative area, let's say in square meters. So as more square meters of vegetative area we have, with higher light interception, more carbohydrates production, and then normally more yields. So let's say all these tests with different types of pruning is exactly in order to have more square meters of leaves and better light interception. And that's the reason why we were looking for this. Now, this is what we call the photosynthesis. And when you call photosynthesis, we have two kinds of photosynthesis. Let's say the gross photosynthesis and the net photosynthesis. What is the net photosynthesis? Net photosynthesis is the amount of, let's say, of carbohydrates or photoassimilates that the plant is producing with photosynthesis, and how much plant is spending for doing respiration. So respiration, it's a natural process that the plant needs to keep the plant alive. So always plant will do photosynthesis, produce photoassimilates, carbohydrates to keep the physiological process that keep the plants alive first. And then the rest or the other amount of carbohydrates or photoassimilates that's not being used for respiration, this is the net photosynthesis, is the carbohydrates that the plant will have as reserve. Let's say we used to say reserve of carbohydrates. And this is strongly linked with temperature. So here you can see at 10 degrees, okay, at 10 degrees, normally the plants stop. And they just start to hibernate it, and so no physiological activity anymore, just to keep the plants alive below 10 degrees. At the 20s, we are more or less reaching the maximum or the ideal level of photosynthesis. And up to 45, 40 something, we are still doing there. And then if you go up to 47, near the 50s, again, plants block again in order to avoid too much stress, a lot of transpiration needed to cool the plant. And even though the plant will not be cooled, so then the plant simply stops. So let's say between 20 and 40, these are the amount of, let's say, or in Celsius degrees, where plant is doing photosynthesis at its best in a normal condition. But with respiration, that's the first process that you consume these carbohydrates or photoassimilates. It is different regarding the temperature. So if you are at 20 degrees or let's say 25, we have a low respiration rate with a high photosynthesis rate. So the net photosynthesis here is huge. So here plant is building up a carbohydrates reserve. If your temperature is around 35, for example, basically your plant is consuming everything that is being produced with photosynthesis just to keep the respirational process ongoing, because the temperature is so high and plants need to do a lot of respiration and as well transpiration that basically is consuming all the carbohydrates that you have. So basically this means that you don't have too much net photosynthesis. What we learned here is that really matter this net photosynthesis, the amount of carbohydrates that we are building up in order to support a good yield. So we invested a lot in, for example, in carbohydrates analysis here in the leaves and these things in order to understand and do the management of the carbohydrates, how they are building up along the season in the plant. I will show you a graphic in a few slides before. But before we go to that and understanding this concept of net photosynthesis and carbohydrates build up, one important thing, and then again a link with the nutritional status with our plant, and then here potassium plays an important role, because as we always know, potassium is the element that regulates the closing, the opening and closing of the stomata. That means regulate respiration and regulate also transpiration. And so you see here, this is a graphic of the concentration of elements, phosphorus, chloride, potassium, and calcium. When the stomata is open, you see a peak on potassium, and the stomata is closed, you decrease on potassium. But you see that the phosphorus, calcium, and chloride, the other elements, they are at the same level. So you only see a change on potassium. Now you don't see a change on phosphorus or chloride or calcium when the stomata is open or closed, but you do see in potassium. So that's why people used to say that potassium regulates the opening and close of the stomata. So keep potassium in ideal levels in our plants. Ideal levels, not excess. Not saying to apply a lot of potassium, because a lot of potassium create an imbalance as well. But keep potassium in ideal levels in order to support properly this process of opening and closing the stomatas, help the plant in regulates respiration and transpiration. And that means be more efficient with the net photosynthesis, the carbohydrates build up. And as well, you see that potassium on the transpiration, for example, you see here the green line, it's with ideal potassium levels. The yellow one, it's with a moderate potassium deficiency, and the red one with a severe potassium deficiency. And this is the answer to the plant. The transpiration, when they induce it, let's say hot winds, let's say on the leaves, so hot winds hitting the leaves. You see here, ideal potassium levels, immediately the stomatas will close after 10 minutes, and then you see a decrease on transpiration because then the stomata is closed. So the answer, when the plant is receiving hot winds with ideal potassium levels, in 10 minutes, the stomata is closed and decrease the transpiration level. With a moderate potassium, you see this take 30 minutes. With a severe potassium deficiency, it's 45 minutes to close the stomatas and then decrease the transpiration levels. So the stress, keeping good potassium levels, it's also about preserving the carbohydrates that we have as a reserve. Because all this, let's say, excess of transpiration when the plant is receiving hot winds will start to decrease. If the plants increase transpiration, increase also the carbohydrates consumption. And we learned it here that really to have a higher yields, we needed to have a good carbohydrates reserve inside your plant. So we are literally doing everything we can in order to build up carbohydrates reserve and keep that carbohydrates reserve in the plant and not being consumed by other processes that it shouldn't be there. So this is the type of thing that it's quite common in our hot area here. You have hot winds. Decrease the expenditure of carbohydrates doing this, just keeping good and ideal potassium levels in the plant. So coming back to our net photosynthesis, this is what we are looking for. We are looking for this is building up carbohydrates reserve with net photosynthesis. And this is a graphic that was done here in our conditions by Eduardo Ferraz. It's a mango advisor that the company, they call it Chlorophylla. And he shared this with us. It's without numbers here because this study was paid by a private company. So we don't have the right to share all the data, but we can share the curve. And this is what really mattered for us, what we learned with this trial. This is vegetative stage. You see here days, 30 days, dias is in Portuguese, sorry. So 30 days, 60 days, 90 days, 120, 150 days, 0, this is flowering. This is when the mango is flowering here. So all this, it was from normally when we do the harvest here, 120 days after flower in average, depending on the variety. Some varieties can go up to 150, but in average, 120. So it's that we do the harvest and then we do pruning and then start to coming, the new flushes are coming. Normally we have 2 vegetative flushes here. And this is why we see this decrease. With 30 days, we start to check the carbohydrates content in the flushes, in the vegetative material. And then this was the emission from the first to the second flush. This is the emission of the second flush. And then when you have the second flush, we start to build up carbohydrates. So our carbohydrates reserve is built up during the vegetative stage. And here, normally between 60 and 150 days, let's say after the new sprouting, after the plants or after pruning in our case, because we always do the pruning here. So normally between 60 and 150 days after pruning, this is the moment where we build up our highest levels of carbohydrates within the plant. After flowering, this is 0 here. Plants always will consume carbohydrates. So it's a fruit is growing. So plant is producing, but also sending carbohydrates to the fruits. So we still have some production of carbohydrates here, but more consumption than production. So that's why you see a decrease here in the top levels. So the opportunity we have to build up a reserve of carbohydrates inside the plant is during the vegetative stage. So that's why pruning is so important and light interception is so important. And then here coming back to to the nutrition again, magnesium is so important, especially here on this time. So if you are using water-soluble NPKs, for example, water-soluble NPKs that does contain magnesium are very welcome. Or if not, you can always add some magnesium sulfate or magnesium nitrate, depending on your condition if you had it. But we learned that in order to have higher yields here from flowering ahead, we needed to have good reserves of carbohydrates before. And the vegetative stage, it is the opportunity to build up this reserve of carbohydrates. So this is very, very, very important for us. And we are monitoring and managing this here in order to support, let's say, the highest yield with top quality for export. That's what we need.
Felipe, sorry, we have a question from Kalum again. Maybe you can ask it directly, Kalum.
Sorry, Felipe, I was just wondering what leaf levels of potassium do you aim for in that pre-flowering stage? Our lab standards it's a pretty wide range from memory, and it's hard to know. It's like 0.3 to like 1.2 or 1.1. I'm just wondering, yeah, it's quite a wide range to aim for. So I was wondering what you guys aim for as an indication of that carbohydrate buildup, and how do you measure carbs directly in the leaf, and how do you do that?
The carbohydrates we are measuring or directly in the leaf or directly in the branch. So depending on the lab. So you need to check with the lab what kind of methodology they use it. So they can do it or in the leaf or in the branch itself. And normally in the labs here, as we do it, I do it more in the branch, honestly. So from my farm, when I do it more in the branch than in the leaves. So this is exactly what we are managing this. Regarding the carbohydrate levels, I needed to wait this study being published, then I can open and share the data with you, because this is not published yet. So I cannot give you today exactly what are the levels that we are looking for, because this is also part of the result of this research. But it's a private company that's paying for it. It will be published. So in the future, I can share this with you. But my advice, and this was exactly how I started, that I can tell you, is if you have an orchard with a let's say higher yield and an orchard with low yield, start doing your own comparison. This is exactly how we started. Then a company saw what we are doing and say, okay, let's pay it for be more scientific on this. In fact, they are aiming to find a product that with this product, they have a higher accumulation of carbohydrates in the plant. That's why they are paying for this. But we started in a very empiric way. Just, okay, we have some areas where we harvest almost 50 metric tons and other areas with 20. Okay, let's start to looking for the difference between the 20 and the 50s. And then we start to look, but in a very empiric way. So now the companies are doing a study to put, let's say, a scientific number on this on level. And it will be published in the future. But I would suggest to you start as we started till we don't have this published yet. So take a good orchard and your reference in your area and start to doing and check carbohydrates. And we are doing analysis, as you see here, maybe all year round when we are doing. But you don't need to do this. For example, you can do it in the key moments. For example, starting doing before flowering and in the middle of the fruit development stages. These are two key points, because then you can compare, okay, this is my program, this is what I did, and now I reach it before flowering with these carbohydrate levels and middle fruit development stage with this. So then we have what you did, and here is also very important that you have the environmental data, which were the average temperature, light intensity, and all these things, because it's not something that you apply one product and you see this increasing or decreasing. The environmental aspect, it's also very important here. So that's why we concern a lot on pruning, because light interception is very important. Temperature, it's also very important. So with the time you start to build up your own data, okay, with these conditions, doing this management and reaching that carbohydrate levels. And then you start to learn how to play with and do it. So building up the knowledge locally, I think it's always the best way.
Thank you.
You're welcome. But keep in mind that start to look to carbohydrates accumulation. This is something that really will make the difference in the orchards. We learned it by experience here. So once we have that one, the other parameter that we use to think in mango nutrition is the mango fruit nutrient extraction. So this is the average of the three main mango varieties that we grow here in this area. That's basically Tommy Atkins, Palmer, and Keith. And what they did it, how they did it is they take a fruit of mango. Basically 85% is just water, so they dry it up, and you stay with 15% as dry matter. And then they analyze the chemical composition of that dry matter. And then this is the chemical composition in minerals of 1 metric ton of fresh fruit that was dehydrated, and then from the dry matter, the chemical composition was analyzed. So this gives to us an indication about, okay, according to my yield, this is the amount of minerals that my fruits are exporting, are removing from the field. So in theory, we should apply depending on our yield. If our yield is 20, let's say 20 metric tons, you can basically multiply this by 20 and you have an idea about how much nutrients you need to apply it. If it's 40, you multiply by 40 and then you have an idea. So this is a kind of guideline that we use it in order to have a reference on which amount of nutrients I should apply during the season according to my expected yield. Obviously, then you need to consider, okay, the amount of nutrients you have in your soil. So I suppose you do a soil analysis, and then with the soil analysis, you can check the levels of the nutrients and then adapt how much you will apply, diminishing the soil reserves that you have. Also to do some soil corrections if needed. And also if you do irrigation, the water analysis. Water analysis, it's very important here, especially for calcium. Calcium and boron, I say it, but boron less common. More common, it's calcium. Because normally a water contains a lot of nutrients, basically almost all of them, but in a very, very small amount. So they're not really, let's say, we don't consider. But calcium is something that often it's present in waters and sometimes it's present in the water, especially if it's a bit hard water with calcium carbonates or calcium bicarbonate in the water, that you could have a certain amount of calcium in your irrigation water that even you don't need to apply any calcium at all during the season for your plant, because sometimes even more calcium than the plant need or will require is already coming from the irrigation water. So it's important to consider that, because sometimes a water analysis can save you a lot of money, especially on calcium application, if you have already some calcium in your water. But sometimes boron as well. Keep in mind, some waters, depending on the source of the water, they do contain some boron, that depending on the level, this boron can become toxic. So keep an eye on boron levels in your irrigation water. It's also a good thing to do. But mainly calcium is the one that you need to looking for more. And in water with very high pHs, you can have some magnesium carbonate or bicarbonate formation. But this is only for water with very high pHs. And normal waters that you use it, normally we need to do it and check it for calcium and boron. And this is how we should use to do the balance of the nutrients. So this, we use it in order to check the amount, okay, how much nutrients we are thinking to apply. So this is the total nutrient extraction from the whole fruit formation. But this study gives it to us a bit, let's say, information on how we should balance that amount of nutrients along the season. So, for example, these are the 3 varieties. So this is the data from the 3 main mango varieties we have here in our area. This is the dry mass production. So this is we removed already all the water from the fruits, and it's only dry mass production from the fruit. So this is days after the anthesis. Anthesis is the moment where the flower is fully open, and then you have the fecundation, and then you start the process of fruit formation. So this is days after the anthesis. So you can see that from the dry mass production, we have a huge peak increase regarding more or less between 35 to 80, 85 days. We have a really the increase, and then the curve becomes more flat again, between 35 and 90 days of dry mass production. So this also teaches us a bit, okay, when the nutrients should be available in the higher quantity for the fruit development. That this is what we are looking for. We want looking for higher yields with export quality. So we need to make sure that the right amount of nutrients, it will be available to the plant at the moment that the plant need. And for fruit formation, the highest, let's say the peak of the dry mass production, it is between 35, 85 days in a cycle from flowering till harvest, 120 days, more or less. So this means, okay, how can we make sure that the nutrients are available here? Fertigation is great for that. So if you are doing with fertigation, we can just change, let's say the amount of nutrients we are applying in order to concentrate, let's say, the nutrients via fertigation during this period. And if it's not fertigated, if it's granular fertilizer applied on soil, we need to make sure that the fertilizer will be applied and it will be available to the plant just before, let's say, this period, because this will be the period where the fruits more will need for the dry mass production. And you see a similar behavior, for example, for calcium and magnesium. Now, if you look at the accumulation of calcium and magnesium in the same fruits, you see that's more or less the same, between 30 to 70 days for calcium, magnesium, it's very similar. You see the uptake, the increase, it's the same as the dry mass production. You can clearly see here as well, for example, this is milligrams per fruit, so this is the amount of the mineral in the fruit, and it's 210, the scale is 210 milligrams for calcium and 70 for magnesium. Is that general rule 3:1, the ratio between calcium and magnesium. And we see that this is exactly reflected, for example, on the fruit, on the mineral accumulation in the fruits. And in the same path for nitrogen and potassium. So here you see it again for the nitrogen and potassium, that's between 30 and 80 days. This is the moments where the curves are going up, then they start to become more flat. Now between 30 also for nitrogen and potassium. And here I would like to come back to the questions of our colleague that before asked between nitrogen and potassium ratio. Here is exactly the thing that showed to us, okay, how can we play with the nitrogen and potassium ratio? Because if we see, I will come back a few slides here, we see that the amount of nitrogen and amount of potassium in the fruits in general are very similar. It's between 1.2, 1.6, so it's okay. It's not much more potassium than nitrogen in general, considering the whole cycle. But if we look at this information, when the fruit is developing, let's look at the scale. Nitrogen, the maximum here, it's 800 milligrams per fruit. Potassium, it's about 1,000. So if we take for example, the Hayden variety, let's take the middle here in the 60 days, we are having more or less 280 milligrams of nitrogen. And if you take here, we are about 400. So this means that's almost a 1:2 ratio. So for each unit of nitrogen, 2 units of potassium. Now you look at here, it's the other varieties are around 200. for the Palmer and Tommy. And if you look here on the 60, they are more or less, for example, here for the Palmer, it's about 350. Tommy, a bit as well, 200. So we start to play with this nitrogen potassium ratio per variety. So for example, for Tommy, I can keep more or less a 1-to-1 nitrogen potassium ratio along fruit development stage. But I cannot do this, for example, for a Palmer. For a Palmer, if I want to have a better size, better color, I need to increase to basically, let's say 1 to 2, each 1 unit of nitrogen, 2 units of potassium during that period of fruit development stage. So the amount of nitrogen and potassium that I will apply in the whole season will be almost the same, a bit more potassium than nitrogen. But during this specific fruit development stage, it's very likely, in order to get fruit quality, that I should use a 1-to-2 nitrogen potassium ratio, for example. So this is how we play with that nitrogen potassium ratio. This is the moment that normally we do it, especially during this fruit formation. For all the other mango stages, if we use a 1-to-1 nitrogen potassium ratio, it is okay. Even a bit more nitrogen than potassium during the vegetative stage, because we will use more potassium than nitrogen during the fruit formation stage. So normally it's 1-to-1 or a bit more, 1.5-to-1 during the vegetative stage, and more 1-to-2 during the fruit development stage. So in general, this is how we play with the nitrogen potassium ratio for this. Coming back to the question of our colleague before. So potassium, as I told you before, it's very important because potassium is let's say the transporter used to take the carbohydrates from the leaves to the fruits. And this is for any crop. It is the design for an apple. But that's why also normally we see these higher levels of potassium during the fruit formation, because potassium is the element that the plant is using to bring the sugars, literally the sugars, from the leaves to the fruits. So then potassium is the element that the plant is using for this. And as well, plants use potassium to fill the cells during the cell enlargement. Keep in mind that when you have the fecundation of fruit formation, then you have the cell division process. This is one cell. So the flower is fecundated, then you have the cell division to start to form the fruits. Then you have the cell stretching. When the cell is stretching, plant needs to fill that cell in order to keep the cells turgid and expand the cell. And basically, plants do this with water. That's why 85% of a mango fruit, or almost all the vegetables, not only mango, it is water. So because then plant is doing cell division, expanding the cells and filling the cells with water. This is a very, let's say, basic concept. And potassium is normally the salt that the plant is concentrated inside the vacuola in order to attract water, because this is the osmosis process. This is also how plants put water inside the cells. It's like our body. If we eat too much salt, we start to have, let's say, liquid retention, water retention, and then we have a higher pressure in our bodies. So it's a bit more or less similar concept with the plants. They start to concentrate its salts, in this case it's potassium salts, because of the mobility of potassium, and then concentrate salts and then attract water and then keeps the cell turgid and expanding. So that's why, let's say, also plants use much more potassium than other elements during the fruit formation and fruit development stage. So keep an eye on potassium during the fruit formation and fruit development stage. Is the best thing that you can do regarding the quality of your fruits that you need. So as we said, water represents 85% of the total mango weight. So we need to monitor water, irrigation, and we cannot correct what we are not measuring. Probably if you think as a farmer, the input that you use most in your farm if it's an irrigated farm, it's basically water. There is any other input or resource that you use more than water in a farm. Then more than, if you compare the amount of water you use with the amount of fertilizer, pesticides, labor, or whatever, you see that probably water is the highest, or the input that you use in the highest amount in your farm. But normally not everybody, let's say, is paying attention on water. Hardly someone have a water analysis in many countries, and hardly they are monitoring how that moisture or that water is behaving in the soil. But water, it's really, really, really important as well, as we just saw it. So without water, you can apply the best fertilizer or do the best management in the world, that without water, you not succeed. So it's very important, keep measuring and tracking what is happening with the water that you are applying. If it's in the right amount, if it's not in excess, if it's in the right place at the root zone, not too deep, not too short, monitor watering, it's really important. So some practical, let's say, tips that we used to use here to support our high yields with higher quality. I'm talking about yields that are in average, let's say the good areas. The good areas, they are in average above 40 metric tons, within between 90 and 95% with export quality. So we are in average above 40 metric tons and above 90% of export quality. So during the vegetative development starts at the pruning after harvest. And that's the moment where we always do phosphorus application. So if you need to do some corrections at phosphorus, normally we always do after harvest and before pruning. So then we correct phosphorus if it needed to be corrected. Otherwise, we just keep applying phosphorus via fertigation along the season. The potassium nitrogen ratio here should be 1:1 or higher than 1 for nitrogen in comparison with potassium. So here it should be nitrogen, potassium, and not potassium, nitrogen. So please don't be a mistake. I will correct this for the version that I will share with Antoine. This should be higher 1 in nitrogen in comparison with potassium. Magnesium, it's really important, as I told you, because of the carbohydrates reserve. Not often people pay attention on magnesium, but keep good magnesium and also microelements level here. It is really important to support the photosynthesis process in order to do the conversion of the carbohydrates. If you remember the graphic of carbohydrates accumulation I showed to you, vegetative stage is the moment to build up the carbohydrates reserve. So for this, good magnesium and good trace elements levels are important. So keep an eye on that. If you need to do any kind of corrections in the soil, we do it at this moment as well. And again, this is the moment for carbohydrates build up. During the inflorescence, emission, and flowering, here calcium will start to play an important role. So this is the right amount to start to apply calcium, especially soluble calcium via fertigation. Phosphorus and magnesium are also very important at this point, and boron and zinc are really important here. Boron for the fecundation, for the pollinic tube formation, and zinc as a precursor of auxins for the panicle elongation in order to have a good panicle size. So boron and zinc, it's critical trace elements to pay attention at this point. In some areas, we also add boron and zinc together with the flower induction. When we use potassium nitrate for flower induction, and we are adding boron and zinc together with potassium nitrate in order to, let's say, make sure that we are safe with these elements when the inflorescence come. And here is correct. The potassium nitrogen ratio here should be already higher in potassium than in nitrogen. Here is the moment where you start to switch for more potassium than nitrogen. When the inflorescence start to be emitted, we start to change this balance and increase potassium in comparison with the nitrogen. For fruit setting, now when you are having a fruit set and initial stages of fruit formation, Here, calcium, it's really important. That's the period where you have the highest content of calcium coming inside the fruit. So here you have, this is the chance that you have to have calcium inside the fruit when the fruit is small. Now, because when fruits are small, they still have some structures like stomatas in order to do transpiration. So calcium is coming in. And as the fruit size increase, these structures, they start to, let's say, disappear. And then less and less calcium go inside the fruit. So this is the best moment that you have to add calcium inside your fruit. Your potassium should be even higher, potassium nitrogen ratio from 1.1 to 1. And also the nitrate ammonium ratio here is very important. Here, from this stage ahead, from the total nitrogen that you apply in this moment, no matter the amount, but from the total amount, ideally, minimum 70% should be in nitrate form and 30% in ammoniacal form. If it's 80-20, even better. And that's why, because nitrate is an anion with a negative charge, ammonium is a cation with positive charge. So nitrate will have a synergism with potassium and calcium uptake, because potassium and calcium are both cations. So to have a higher nitrate participation during this stage instead of ammonium, it really helps the plant to uptake more calcium and more potassium. So this is also, let's say, an ideal moment. For example, if you want to use it, nitrate-based fertilizers in comparison with ammonium-based fertilizers. On this stage, if you want to have more ammonium, do it on the vegetative stage, because then the requirement of cations like calcium and potassium is lower by the plant. But during the fruit formation stage, use more nitrate than ammonium during this stage. This is really key in order to have a fruit quality, especially for calcium content in the fruit. Irrigation management, it's also very important here on this area. We cannot have any lack of water here because this is, sorry, for caliber and calcium content, because calciums go through together with water to the fruits. So if you have a lack of water here, that means a lack of calcium inside the fruits as well, and also caliber. So this is also a really critical moment for irrigation management. And during the fruit development stage, when the fruits are closer already to the final size and maturation, then you can really have a calcium reduction. Hardly you have any calcium going inside the fruit from this stage ahead. So you can focus more calcium at the beginning of fruit formation and reduce calcium at the end of the cycle. The potassium nitrogen ratio already really high here, it should be 2:1. And the irrigation management here, it's also important, because here, when the fruit already reached the size, you can diminish a bit the amount of water you are applying in order to control, especially the bricks with the fruit. So let's say, to come this to an end, what we are looking for with fertilization in mango. As a farmer, this is I read it as a farmer, it's first, support a high production load. This is what I really want as a farmer, that my fertilization scheme do. With fruits, with quality enough to reach the markets with the best prices, that for us is the export market. And also gives plant stability to achieve high yields on consecutive seasons. I don't want to have one season with 40 and the next season with 15. That's not on interest. I have to have a 40 and then 40 again and then 40 again and then 40 again and always 40. So this is what we are looking for. So this means that from a nutritional management perspective, I needed to supply nutrients to support the high yield on this season and build up a good amount of carbohydrates reserved for the next season. Nutrient use efficiency, especially regarding to avoid environmental impacts. That means all the nutrients that I will apply will be used by the plant and will not be, let's say, contaminated groundwater and other environmental issues. So, and also for cost reduction, if I'm being efficient with the nutrients that I'm using, I'm also reducing my cost and adapt all these to the local reality. So sandy soil is a completely different than a clay soil. Water management depends on the water sources that you have, if it's well water or river water. Cation retention on the substrate or in the soil that we have. So it's many parameters interfere there. That's why we are agronomists. So we needed to adapt all of this. So basically, if we to have a good fertilization, let's say the key point is knowing what we need. It's basically that 4 R's concept: the right source, right place, right amount, and right dose. So if you have the answer for these questions for fertilization, okay, when will I apply? And that's according to phenological stage. Where will I apply? What dose I will apply and what source I will apply? And mainly the source here is regarding to keep that nitrate ammonium balance and the nitrogen potassium balance. Doing this, if we have the answer for all these 4 questions, that's basically the 4R concept. That's the first step to develop a good fertilization scheme, a good nutritional program. So when to apply, it's really according to phenological phases. If it's just in a single application, the more we split the applications, better or higher will be the nutrient use efficiency. And fertigation, it's really a key thing for us on this. With fertigations, give to us the opportunity to split the ratio between the elements and the amount according to phenological stages. So with fertigation, we are doing this directly where the roots are. So you see, normally this is drip irrigation. So roots are concentrated here. And with fertigation, if you apply nutrients, they go directly where the roots are. If it's not irrigated, imagine that this is a mango tree, this is the trunk, and this is the canopy. Please concentrate the granular fertilizer on the last third of the canopy expansion, because this is where we have the most active roots. Many people apply near the trunk, the fertilizers. It will be more efficient if you apply in the final part of the canopy expansion. This is where we have more active roots. Regarding the source, this is really important for the fertilizers. Check the chemical compatibility between the applied elements. The presence of some unwanted elements, like sometimes with some fertilizers, you can apply excess of chloride or excess of sulfur, excess of sodium. Depending on the source, some heavy metals could be present on it as well, cadmium, arsenium, this kind of things. So make sure that you are using a good source. Solubility for fertigation is very important. And the form of nitrogen. How much is not only, when you think in nitrogen, don't think only in how much, in the amount of nitrogen you are applying. Think as well in which form of nitrogen you are applying. From the total nitrogen you are applying, how much is in nitrate form, how much in ammoniacal form, or urea in a very simple way. Sorry. And the main difference here is because this nitrate is an anion and ammonium is a cation. And this, from the chemical perspective, antagonism and synergies make a huge difference, especially during the fruit formation stage. So pay attention also on the form of nitrogen, not only the amount of nitrogen you are using. So just to show you just a few pictures to end this presentation. These are pictures from the farm I have here in Brazil. For example, this is variety kit with 333 plants per hectare. And you see here that last year we harvested 44 metric tons per hectare. And this is kit variety. You see the quality of the fruits. It's a very good standard. In this area, we exported last year, the export rate, it was 93%. So we have 44 metric tons with 93% with export rate. This is the same area, just another picture. You can see the uniformity of the fruits in average. They are with a very uniform, that's why you have so high. We use all these principles that we discussed here. Is the principles that we are using in these areas that I'm showing to you. This is Palmer, other variety. The other one was Kit. This is Palmer. This is high density. It's 1,111 plants per hectare. And this, you can also see here, let's say the still young plants. So I do expect that in this area in the future, the Kit variety, they are older plants. And these one are still young plants. So I'm still, let's say, hoping to see this number growing, and I expect to harvest more on high density than I'm harvesting on the low density orchard. But you can see, let's say that it's very uniform, the shape of the fruits and the amount of fruits per tree. So this is why we are, let's say, we are reaching here, let's say, highest yields in mangoes. So thank you for your attention, guys. This was a bit content I prepared to share with you today.